My name's Robin. I used to work at ThoughtWorks, who I'm sure some of you would have heard of as a consultant going in and helping companies deliver software better ways. And this talk is kind of an experience report from one of those engagements. I've since left ThoughtWorks and I work at somewhere called Digital Ventures, which I'm pretty terrible at explaining, but it's basically business building as a service, so kind of startup incubator type thing. So if that sounds interesting, we are totally hiring. Come and talk to me afterwards. Turns out continuous delivery is super important in that world too. Who knew? Anyway, so let's get started. So with all of this, the caveat is context is everything. This is an experience report, what worked for us, what I wish I'd have known at the start. Hopefully some of this applies to your situation. You can maybe take away the bits that you want and say, actually, that bit doesn't apply to us, and leave it over there. So bit of context then. So we were working basically all of last year at a client in the legal industry. Who it is, doesn't matter. And they were trying to migrate a new product into market in the UK. It's popular in the US, had done really well, trying to market to the UK. So they were kind of in an interesting situation of having a legacy code base that had yet to go into production, which is a nice little combination of things. Software as a service product, lots of data, kind of big monolithic system, globally distributed development team. Have we got 50 plus developers? Oh, and doing a cloud migration at the same time. So it ticked a lot of those boxes. When we landed, we did some code complexity analysis on the code base. So just want to give you an idea of what we were dealing with. Here it is. And this was us. We owned this little bit here, and then the rest was everyone else around the world. So obviously, CYCLOMATIC complexity doesn't tell you everything, but the code base wasn't in a great state. About 1.4 million lines of code altogether. The code really isn't the important bit. So what were the consequences of this kind of code base and the way that the teams were working? 3 months to deploy a new feature. I'm sure we've all worked in companies where it's kind of those orders of magnitude commonplace. High defect rate, lots of rework. Coupled release schedule. And what I mean by that is, say we have a test environment with 3 different systems in, systems A, B, and C. You test them all together, and you're like, they finally work. That all looks like it works together. We can never separate those systems ever again. And so those 3 systems march through subsequent environments all the way into production together. They can never be split up because that's the magic combination that works. So when I say couple release schedules, that's what I mean. Code freezes, oh, that works. No one touch anything apart from hot fixes. And if you need a hot fix, you have to fill in these forms in triplicate to get it through. That kind of stuff. Knowledge silos. I guess with the globally distributed teams that happened. We also had some lovely, we had lots of architects dotted around various ivory towers, DevOps team, obviously a standalone DevOps team. And then we discovered another DevOps team that actually the first DevOps team didn't even know about, so we introduced those to each other. Another ops team. It was like, I'm sure some of you have read the Phoenix Project and those other novelizations of a kind of, to exhibit problems. It felt like we were living in one of those, basically. So actually, that made it a great learning experience. Knowledge silos, low team morale, because at the end of the day, as developers, we want to deliver value to our users. That's the whole point. That's what we're in it for. And if you're just spending your whole time slogging through nonsense code and being trying to fill in forms to deploy code releases and then only every 3 months, that gets your spirits down. And the big one, and this is why essentially they got us in to help, was they were losing in the marketplace. They were number 1, they were dropping down to number 2, and it was only going in one direction. And suddenly, people in the business start to pay attention, right? And then they come to us for answers. So this is what we did. They came to us and said, we've heard about this continuous delivery thing. We think it's going to help us. We don't really know much about it. Can you form a continuous delivery enablement team and sort everything out? And we were like, well, it's kind of an anti-pattern. And the why we thought it was an anti-pattern is that it would just create another silo of knowledge, and that team would own continuous delivery. And actually, in the long term, that would slow it down. And what if we did do some good stuff, but then left, and then you're just in a worse place than you were before? But we talked it through and said, you know what? We think we can make a difference. Let's jump upon this opportunity. We'll have to work around it a bit, but we'll rather take this than not engage with the continuous delivery stuff at all. So we put this team together. It was a couple of us dirty consultants, but then we got 2 or 3 developers from existing teams. It was really crucial that we had people who'd been at the coalface working on the code base, got them in as well. and run it as a standalone team. So what I'm going to talk about now is the learnings that we had for running and working on that team for the best part of a year. So what I kind of wish I had known at the start. So, first things first, it's not about the tools. Like, I know this is a really, maybe not a great thing to say at a conference where some of the talks are about these are the great tools you can use to enable continuous delivery, and so take it with a pinch of salt. But our point was that I think the expectation on us initially when we went in was like, oh, you're enabling continuous delivery, well, just tell us what tools we can use. So if we'd have just walked in and said, well, you need to go for continuous delivery, Docker and Kubernetes, and maybe implement them, and then, off we go, that wouldn't have fixed a thing. The exact same problems that were prevalent would still exist. You'd have just solidified them around some new tooling. And so we learned that tooling can't fix your culture. Like, I'm afraid that there's nothing you can buy that will fix your culture, because at the end of the day, usually comes down to people. It's always people. So, I mean, this is a nice shot I found on the internet. This is the state of CD tooling at the minute. I'm sure lots of you are familiar with a lot of these. But to be honest, flipping one out for another in the same box, it's not really. Is it going to make that much difference? I mean, a concrete example for in our world, they were using Jenkins. It's been around for a while, does the job. It's not great for CD. Pipelines is a first-class concern. It's kind of come in. But trying to fight that battle and say, well, we think you should switch out for something else, it just wasn't worth it. We needed to focus our efforts elsewhere. So yes, we picked that one up early, and that saved us well, and we had to deflect a few arguments that came our way around tooling. So these are the real challenges we're facing. Not proactively addressing problems, and that's just simple stuff like the build failing, and it just sitting there because, it was probably someone else. Oh, that one always fails 1 in 3 times. Things like that. Resistance to change. I mean, this is a classic. Every organization has antibodies, much like our bodies do. You might have heard this term before, who kind of react and try and push out any change to them. And an analogy I like is the form of organizational scars, which form after an incident. So let's say at your company there was a production outage, a deploy went bad and there was a production outage and it brought stuff down for, half a day or something. And once you've fixed it, you kind of have your post-mortem. You say, well, how are we going to stop this happening in the future? And someone says, we'll introduce a process to stop this mistake being made. So that process gets written down somewhere. Let's say you have to fill in this form. And someone's job now is to make sure that form gets filled in. That is their job. And so that has now solidified as a process. But then that person, after 5 months, 6 months, leaves the company, and they get replaced by someone else. And as part of their onboarding, you say, and part of your job is you need to fill this form in when this thing happens. And the person nods and go, okay, cool. And they do that. And then they leave, the next person comes in, and it just kind of carries on. Even though the actual original cause of it has been mitigated and doesn't even exist anymore, that process still remains in the form of a scar, and everyone has to kind of work around it. But when you go in and say, why is this scar here? And you try and rip it off, the person goes, but that's my job, that's what I do, I maintain this process. So the form bit is a bit of a glib analogy, but this totally exists, and it will exist in other ways, and sometimes even job titles. And so you're really, again, it's all about the people, that's what it comes down to. Breaking down silos, I've talked about already, when you have your standalone DevOps teams and architects and so on. Communication, people didn't talk, so you'd often find reinventions of wheels going on. Getting people to care and understanding the benefits of CD. Unfortunately, continuous delivery is now, it's a buzzword along with a lot of other things. Our job is to change that, and I'll talk around some of the aspects of how we actually went about changing that. But we had one quote, I've got it here, from one of the senior architects when we kind of got to work, and she said, I think you should stop concentrating on all that futuristic stuff. And we kind of went, okay, well, when you say futuristic stuff, what exactly do you mean? And she said, automating the building, creating artifacts, and then deploying it, through environments. So we said, continuous delivery, and she was like, yeah. So, but this is true, and this is a senior architect, and she was a smart woman. So there is still a lot of misunderstanding around what this is, and so you have to kind of sell them on the benefits of that. No sense of ownership, very similar, and not empowered to affect change. So even though people knew that something was a problem and what could be done to fix it, it's still quite a long way, a big jump for people to make to put themselves out there to say, well, I'm going to do something about it. I'm going to push that agenda forward. So I think that's kind of why they got us in, because we have less at stake, and so therefore we could help push that agenda a little bit more. And there were some capability challenges as well. Testing, it's always testing. Hopefully a lot of you are familiar with the test pyramid. This is Martin Fowler's version, but a lot of cheap tests that you run that are quick, and you run them a lot, and then you go up, down, to all the way up the stack to some maybe UI ones, but not so many of them because they're more brittle and slow and so on. So we'll get onto the testing a bit later. Lack of CI tooling understanding. There were pipelines set up in Jenkins, but they weren't created by the developers writing the code, and no one really wanted to touch anything in case it broke. And there was a cloud migration going on as well, and people weren't very upskilled in that. Cloud one, less so important, but the testing one's kind of key. Anyway, so what did we do? So we thought, right, well, we don't want to go top down, because that is what's happened throughout the history of this company. We want to go bottom up. So instead of just saying this is the solution, we want to get together with all the people involved in this who are actually at the coalface doing the work and say, how are we going to fix this? Like, we had a good idea of what the solutions might be, because you see the same patterns emerging, but you really need to get in there and work with the people who are experiencing the problems, because then people feel a sense of ownership and feel they can advance it forwards instead of just being told what to do. So we ran a series of small workshops where we got everyone together, all in one room. So we had representations from all the teams, and these weren't like the architects and the team leads. These are the developers, these are the QAs, these are the people who would work on this every day. And sure, we had team leads and so on there, but we really wanted to have people who were working on it, working on this stuff day to day. What we also did in advance, and it's quite a useful thing to send out, we did a CD readiness survey, and I've blurred it out because it has team names in that might reveal who company is and so on. But we basically asked a bunch of questions around different CD capabilities. So how often do you commit? How long does it take for a commit to get to production? Data management techniques, things like that. And just asked for a very simple score, and then we plotted it out. You can see it's mostly red, so people were quite honest about the situation. There was always a few funny things where two people in a team, one would say, things are fantastic here, and the other would say, things are not so good. And it was always the architect or the team lead that thought things are like this, and then you ask the developer and they were like, it was like this. So, but it was just a sense check. Anyway, so the first thing we did is visualize the problem. And someone taught me this exercise a couple of years ago, and I've used it everywhere I've gone. It's so valuable. And it's super simple. This path to production mapping, which is basically, right, big blank bit of paper, what happens from when the developer commits code until that code goes into production? Every step, everything. Automated, manual, whatever it is. You draw it out, and you don't put too many constraints on it. It's nice to have a key, so if an artifact's created, maybe put those artifacts in one color post-it, and if there's a person involved, you put that in another color post-it, and you draw arrows between it. And you should make sure the reason you do it on a big bit of paper and with sticky notes is because this stuff has to be malleable, because you're like, oh, actually that bit doesn't happen over there, it happens over here, let's shuffle it around. If you're drawing it out in a digital tool, it just becomes harder. And this is nice because everyone collaborates, which is super important. And you'll often find, you'll get to a bit and you're like, oh, I don't really know what happens there. Bob owns that bit, and so then you go and get Bob. You say, hey, can you fill this in? Or it's another team or whatever, which is obviously a sign in itself. But you go and you fill these out, and it's quite a cathartic experience. This one we brought over, the workshop's in America, we brought this from the UK. So this is the team I was on. This was our path to production. Actually, it's not even path to production, it's our path to dev. So, and it's snakes. So yeah, a fun situation. Hopefully yours won't be quite like this, but just an example. And there's another one. Again, you see they ran out of space and had to snake back round. But this is super useful. You need to know your environment before you can start to try and change things. Otherwise, you're just randomly picking things to improve based upon essentially stuff you might want to learn, really. So the next step, once you've got that down, is you annotate it with all the pain points. So the pain points, these are all the pink stickies. You can see them all littered with pink stickies. These are the pain points. So these are things which cause friction, maybe have risks. So for example, if you, at some point in this process, you have to manually enter a release key. And if you get that wrong, you can accidentally release the version of the library you're publishing to the application in the United States and push it to production as opposed to the one in the UK. Ask me how I know about that. And friction points around. You also, at this point, add the timings on, and this is really important. So you can see here, you've got these kind of bars. So it's basically, for every step, how long does that step take? Your tests run 10 minutes, put 10 minutes on. We run the Selenium test, that's an hour, whatever it is. But also, and even more important, is you add the queue times between each step. Because the queue times are the thing that will kill you over time. It doesn't matter if your tests take 10 minutes to run. If you have to wait, on average, I don't know, 8 hours for someone to approve the pull request. You know, optimizing the test isn't going to do anything. So you want to get all the queue times down, all the times, and they become obvious frictions because you can order them by time. So you get all the all the pain points, all the timings, whack that all on. That is a fun experience. And the key themes that arose here are stuff you would expect, to be honest. Lots of manual steps, lots of waste due to high queue times. And when you can just add the times up. So it was taking about 75 hours for us to get from code commit to the first dev environment. And this is an extreme situation, but that wasn't really a known thing. And when you add it all up, it's kind of quite shocking. Lots of things like binaries not being built once, being built multiple times, that stuff. I mean, that was specific to our example, so yours will be different, but these are kind of common patterns. We knew about these in advance, but it was nice to see them called out here. We then kind of took a step back, and it's always nice just to step away from the current world and just do an ideal path to production. Say, if your application, forgetting about the current constraints, what would you like it to look like? And these look a lot simpler. And this is where you can kind of seed in some ideas. Well, how about, you know, you did just build that binary once and then version it and pass it through. And how about you did be able to have much fewer UI tests and more unit tests and so on. So this is quite a nice thing. And then you go back to the real world. What's key here, though, is coming up with these ideal paths to production. And having gone through the pain points before, is you've done it with the teams who'll be owning it going forward. So there's a real sense of ownership there because you came up with it collaboratively. It's not like you said you just have to do A, B, and C. And so there's a real sense of ownership, and they feel they can move it forward. Then you go back to the other one you had. You pull off the pain points, put them all on the top, and we just did a kind of impact analysis, like what is the actual impact of this thing. For the timing ones, it's quite obvious, but some of the others, you just have to make sure the impact's out. And then we just did a voting exercise, because you can't attack everything at once. You should really only go after the bottlenecks. You know, theory of constraints, there's always like one bottleneck, you go after that, then you go after the next one, and the next one, you keep going like that. So you can't do everything. So we just did a simple voting exercise, and top 5, we came up with some suggested solutions, which, I mean, you just read the continuous delivery book. It's not like we were reinventing anything crazy. But this way, we kind of filtered it down to these are the immediate things we want to work on. And then you also have your backlog there that you can always revisit. So this exercise, basically, it took a day and a half, but got us from a lot of kind of nebulous chat about tooling into concrete, specific things that would make a difference. So yeah, a useful exercise to run. So have clear and visible goals. So again, there's confusion around continuous delivery as a thing, what it is. So like from day one, we want our elevator pitch, because people are going to come up to us and be like, what are you doing? You're automating some stuff or whatever. So we're like, nope, let's write down and pin it on the wall and shout it from the rooftops. This is what our mission is, and this is what we're on the hook for. So yeah, our high-level goal was to enable teams to deliver features faster and with higher quality. Short and simple. But how are we going to measure success? We had 8 weeks initially to improve the following metrics. We went for time taken per successful deployment, absolute number of successful deployments per day, time taken to fix a failing deployment, so that's kind of mean time to recovery, and time from code commit to deployment, lead time, which is kind of the key one. And we didn't just make those up. I mean, those are from the State of DevOps report as key leading indicators of a successful IT organization. So we just got them from them. But that gave us something to shoot towards. And what this is actually really useful for is not just saying what you are going to do, but what you're not going to do. Because what will happen is people will come up to you and be like, oh, you're doing automation. Can you create us another test environment, please? And instead of having to go, well, I don't think adding another test environment is going to help, you're like, how will that impact these? And if it doesn't, I'm sorry, that's not what we're here to do. So you can be quite brutal about what you take on and what you don't based on this, because this is kind of the agreed upon manifesto. So yeah, it's all about moving the needle on those metrics. We were really keen to run as a proper team. And what I mean by that is we wanted to be public. We didn't want to be just locked in a room and people say, oh, what are they doing in there? Or something to do with continuous something. No, you run as a team, and this is part of our strategy about being expendable. We wanted to be able to step away and for things to carry on. So we ran it as a team with a big board up with the work we were working on. We split work into stories. We had showcases, we had retrospectives, we treated it like you would a normal team. We invited anyone to come, and we were even more proactive in getting involvement in our team than we would normally. So we rotated people from other teams through ours. So they had a kind of rota and they'd come on and they would just work on stuff that we were working on. We'd save some stories up if they were particularly useful for other teams to work on with us, and we'd pair with them on it. And and go through it like that. And we had a backlog of work, and we prioritized it. But what we did is we prioritized it based on our hypothesis around which of those metrics it would impact that we saw previously, and how much. So that was driving everything. This one tripped us up, and we really should have thought about it in advance. And I still see this now. Everyone's trying to do cool stuff with containers and things like that, and they're not actually practicing continuous integration. I mean, this has been around for decades and decades. And so you kind of think you're doing it, and this is, again, as an ex-ThoughtWorks employee, I have to mention Martin Fowler like at least 5 times, I think. But this is the CI certification test, and the first one trips up so many places, which is every developer commits at least daily to the shared mainline. So on that notion, if you're doing some kind of pull request thing and your pull requests are open for longer than a day, you ain't doing that. You're not practicing continuous integration, and therefore you can't really practice continuous delivery. So this is important. Every commit triggers an automated build and test. That's easy enough to do. And the other one, if it fails, you've got to fix it within 10 minutes. So the fix it within 10 minutes obviously implies that your pipeline can run within 10 minutes. So anyway, lots of places don't actually do this, and it will continually trip you up and cause you pain. And where we were wasn't as well, so we took some steps towards that. An obvious one was when we did the diagramming out of stuff, you end up in these ridiculous situations where you had to open a pull request, but the pull request could only be approved by a team that was in the United States. So if you got unlucky with time zones and created your pull request, I think it might have been like at the end of the day, you might sometimes have to wait 2 of your days for someone to approve it. Ridiculous. So that was solved very simply by just saying, please, can we have pull request rights to, this repository or whatever, and we got them. Pull requests became boring after a while because people were starting to write tests, and then we just got rid of it completely. And that knocked off like 24 hours from your lead time with 0 technical work. So that's why you put the times in, so it makes you attack the right things. And it's not a fun one to attack, going to attack process and scars and say, we don't think this needs to be around anymore. It's much more fun to be like, ooh, let's go and spin up a Kubernetes cluster over here or whatever, but because that's the world we know. But again, it will always usually end up at people. Make data-driven decisions. That's how we would like to work normally, right? At the end of the day, we're putting stuff out there in front of customers using our products. We want to measure how they're using it so we can improve. I mean, that's agile. It's that feedback loop, that constant feedback loop. We wanted to do the same thing here. Because CD has this slight buzzword thing about it, if you make it about the data, it takes opinion out of it, it takes emotion out of it, and you can focus on a problem that isn't your opinion. It's a thing that's over here that you can talk about. So yeah, data will beat anecdotes most days of the week. So here's a couple of examples where we use data. So the first one is this UI test suite audit. So I mentioned earlier about the test pyramid. The test pyramid here was more of like a capital T, with not many unit tests, not much else, and then a huge hunking suite of Selenium tests. You may have worked in such a place. I've seen it a lot of times. There's various reasons why you end up like that, which I don't have time to go into. But yeah, it wasn't working so well. Like, they constantly failing, but they would run. And the ridiculous situation that we were in was that the Selenium tests, there were so many of them, they took about, I think it was like 11 hours. No, it was like 13 hours to run the whole suite. So that meant you could actually only deploy like once a day, because otherwise the test would still be running when you deployed again, and so it would make the test even more pointless. And so you ended up with this kind of tail wagging the dog situation where the length of the test suite was driving the deployment frequency. So we could have just walked in and been like, you need to get rid of the tests. But you're talking sunk cost here. There was like years and years of people writing those tests. There were people whose job it was to write those tests. And, when you hire an automation tester, that's what they're going to do. That's their job. They're going to write automated tests. And so us coming in, we had to be quite tactful about it, because we said delete them or declare bankruptcy, then that would cause a lot of pain. So we needed data. So we basically scraped data about all the tests that have been run, the last 10 test runs, and just put this together. So you can see some averages, I think talked about it, sometimes it's 10 hours. This is all about stability, that's what we're going to show. And you can see here that of all the tests, so 26%, 27% always failed, always fail. Only 0.9% always pass. This is for 10 runs. But almost the worst, like I know as a developer, when I write a unit test, the worst ones are the ones that pass or fail sometimes. They're the ones that get you, right? The unstable tests were the vast majority. So we could step back and say, what value is this adding? Because obviously what happened is that they couldn't put it as a stop the pipeline if the tests failed, because they would always failed. They would always fail. And so people just carry through, and then it would just, you're in ridiculous situations where you go like, well, 72% of them pass, is that good enough? Like our software is 72% good, and so, well, I guess it has to be, but a different 72% than last time. Like, so you can see, like this is obviously an extreme example, but think about where this might have happened in your world before. Anyway, so this, we clearly, so you're basically waiting 13 hours to make no decision and then carry on. So we were like, well, we need to declare bankruptcy, and we got that approved in the end, and it was a very, very satisfying moment when we deleted all those tests. But the fun thing was, slight aside, is that we're like, okay, what we'll do is we'll just write a new simple framework, because you probably still need a few of these Selenium tests maybe, and we'll write a nice simple framework, some examples, and then you can come in and add a few more, but then add a lot more underlying unit tests and integration tests. You don't have so many of these. And so we wrote the nice framework, kind of handed it back, and then straight away people just started to begin to rewrite the 632 again. Of course, because that was what they did before. So then we had to take a step back and say, actually, we need to do some workshops, we need to do some more programming sessions around how to take what was originally a like Selenium UI test at the top and how to break it down into some integration tests and a bunch of unit tests, so you don't need that test at all. So again, capability and kind of skills and people and so on. We put our, when we kind of, after our 8 weeks, actually it was about 6 months in, we did like a finger in the air estimation and said, how much of the time of us working as a team have we been actually doing technical work ourselves? And we reckoned it was about a quarter of the time. So the rest of the time, it was all enablement and talking to people and this kind of stuff. So yeah, it wasn't a kind of classic coding gig. So that was an example. And this is the thing I'm probably most proud of that we did. And this is heavily inspired by Steve Smith, who some of you might know, who's doing a great talk tomorrow on measuring continuous delivery. And I just ripped it off from him, basically. But what we did is like, hey, we're on the hook for measuring these particular metrics. Instead of having a report that runs and scrapes on us working it out, let's just build a simple dashboard that shows what they are. Because then everyone can see it, it's out there, and the data's out there for people to see. So all this basically did was scraped Jenkins for details about test runs, hit the API. Had to do some more stuff because of the way that the builds are put together to work backwards from a certain build, which commits went into it. So you had to kind of track backwards to work out lead time. But that was doable. And so I'll just walk you through what's on here. So this is the main one, which is lead time. So you've got kind of as time goes by along the bottom, and then absolute days up the side. So basically, how many days from code being committed did it take for that code to go into production? Let's talk about that spike later. Then this big other hero one down here is mean time to recovery for different environments. You've got your average time from code commit to deployment up here. So at the minute that was sitting on 8 days. And it goes green if it's improved, or red if it's getting worse. Mean time to recovery improvements, for environments. Here we've got the lead time by for stages. So it's basically your pipeline, but split into which stage is taking the most time, so you can work out where you need to attack next. So we get to see here that the main time is taken up by code commit to package publish, where it's creating the artifact. So that's where we need to go. And then these across the middle are just some other metrics around how many successful runs per day, successful pipeline run durations, that kind of stuff. So anyway, this spike was, and it shows here that around October 13th or something, some code was deployed that had been written originally almost a year ago, so 345 days ago. So when this showed up, and we're like, oh, there's a bug in our charting thing. But no, we looked back, and yes, there was a code in a kind of dependent library that had been, code changes that had been made and only just been slurped up into the package to go into production. I mean, just think, the developers that wrote the code probably don't even work there anymore. So if there was a bug in it, I can't remember the code I wrote last week, let alone a year ago. So, but this was really cool, and this is really powerful, because this was a great tool to go into and start showing to non-developers, so product managers and other people, and getting them on board and saying, this is the current state of affairs, this is why you need to let your team spend some of their time working on continuous delivery and speeding up their pipelines. So yeah, and it allowed us to be experiment-driven, because we'd have a hypothesis, we'd make a change, automate something, whatever it was, and then hopefully we see an improvement here. And if we don't, we reevaluate and we attack something else. So we then, in the dead of night, got loads of HDMI cables and monitors and just absolutely smattered the place with them, and just put this up, commandeered the TVs, and so on. Just because it was a really interesting conversation starter, just watching people see it, read what it was, and say, why is there a big spike there? Why is that going down? 8 days, that seems a long time. Whatever it was, it's a good conversation starter. So, yep, he who holds the HDMI cable has the power. And these are the results after the first 8 weeks. So again, this is all specific to our context, and as you can see, there was a lot of low-hanging fruit. But still, what do? We got code commit to deployment time down from 18 days to 5, which is good. Pipeline runs per day went from 1 to 7. Pipeline run durations went from 10 hours to 15 minutes. That's what happens when you delete a Selenium test suite. And this is the one I like. The mean time to recovery went up by an infinite percentage, because and I'm not making this up, there had never been a green build in the history. And so, hey, brilliant, good stuff, right? But low-hanging fruit. But okay, so I've talked about before about it might be an anti-pattern. So what did we do to make sure that we could make ourselves redundant? Because we didn't want to be doing this stuff forever. We didn't want to become a silo. So actually, there's got some. Yeah, so it was all about enablement, basically. That was a key part. And so our first thing was just, instead of, people don't like, just telling you what to do, lecturing at you. It's much better to give people who are working at the problem the tools to fix it themselves. It might take a little bit longer in the short term, but long term you're going to have a much healthier organization. So we just bought a load of, the Jez Humble and Dave Farley's continuous delivery book, left them around, did some sessions where we could read through stuff. We downloaded the State of DevOps report, which if you haven't read it is fantastic, especially because it helps you give examples of what the industry looks like, without giving your own opinion. You can say, look, there is statistical evidence here that X, Y, Z. So yeah, really good. Give your people the tools to solve their own problems before you hire in consultants. And I'm saying that as a former consultant. There's always people looking for quick fixes, but actually, if you grow your teams and give them the skills, they'll do pretty amazing things, because they understand the systems that they're working with much more than an external person could. So yeah, that was pretty good. We made some pipeline changes, which is kind of key to getting the times down. Built a simple dashboard just to show the Jenkins build as pipelines. And what we did is moved it to pipelines as code, which I don't need to talk to you about that really. It's good practice, but that was really good for getting other teams involved. And that stuff really helps for ownership, because before, if you wanted to make a change to the pipeline, if you were in a team, you'd have to go in, log into Jenkins and click around and do stuff, and it might break or whatever. But now that code was sitting in a folder in their own repository, and so they suddenly felt much more ownership over it, because there it was, and they could make changes to it, they could view the history, they could pair on it with people. It felt a lot more safer, and they could iterate on it. So we kind of helped build a shared library of commands that they could use, and did a lot of demos and a lot of workshops with people so they could feel they could change it themselves. So this isn't, I'm not going to go into the technical stuff, but it was all about the kind of collaborative approach that we took. We over-communicated deliberately. So I talked about showcases before, lots of showcases. And our kind of hack that worked really well was we stuck on our Kanban board, we deliberately stuck a broadcasting column in. So that sat before done. So anything that flowed through had to go through that broadcasting column. And what that meant was different for different types of stories. But every time something came through, we'd have to consider, how are we going to tell everyone else about this, about what we've done, so that they can pick it up and work with it. So whether that was, again, through some workshops or a video recording or a wiki entry or whatever it was, we would decide on it there and make sure. And sure, that took time, right? And that ate into us getting stuff done, but that was very much a definition of done for our team. It was key to the whole enablement thing. Yeah, so that was a nice little trick that we put in early on, and it seemed to work. And then we're kind of coming, there are some things that were easy to fix and would make improvements, but then there were lots of areas we came across which weren't directly within our remit, but we could see they were really placing a glass ceiling on the continuous delivery capability. We'd only be able to get things up to a certain speed or frequency, say the deployments, without changing some of these big things, and that wasn't something we could just go in and make a change to. So I'm going to talk about how we attack those, armed with some of the stuff I mentioned before, like the data. So, hey, I made it to 36 minutes before mentioning microservices, so here we go. What we could have done is walked in right from day one and said, oh, there's a monolithic thing, you need microservices, 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 and just, started hacking the thing to bits. But that, again, wouldn't have gone well. People would have been resistant to change. It would have bashed up against stuff, and it might not have worked. I've seen the scale of microservices disasters to actually where it actually helps you it's like 10 to 1. It's ridiculous. And it's a buzzword now, unfortunately. But here in this instant, we kind of got to a point where this monolithic thing is slowing us down. We have data to show it's slowing us down. We have a hypothesis that if we start to splinter off specific functionality in a kind of given domain from this monolith as a microservice, that will be able to improve the frequency of delivery. Because we had the data, we could kind of pose that as a hypothesis. So we, armed with this, we went and said, we didn't say we're going to do the whole thing, we said we're going to do one. And so we spoke to the CTO, and he said, yep, let's do it. So we found a candidate team who was just building some new functionality, and worked with them. They did it, but we worked with them to slice it off. And again, I'm not going to talk about the technical details of how we did it. There are other talks here about that, and loads of stuff online. Sliced it off as a separate thing, but the key thing was it could be deployed independently by the team that owned it, which is the key bit of microservices that often seems to get missed. So we did that, and it was proxied through the original monolithic thing out to this new microservice, and measured it. And guess what? It was orders of magnitude quicker to deploy that new microservice. The failure rates were lower. And you could prove it because you could compare the data. We say, look, this works here. You can see it. You can see it in the numbers. And that the dashboard that we prepared earlier, we built it in such a way that any team you could just point it at a repository or an application, and it would show you the stats. So we could just compare apples with apples and see. Again, very relevant to Steve Smith's talk tomorrow. So we did that, and that worked. So this was carrying on. I mean, a microservices changing to a microservices architecture is not something you do immediately, so they're still continuing to roll this out. But we went in with data, and we proved that this was a good thing with data, as opposed to it being an architectural opinion. And another one, contract testing. Again, another good tool that kind of goes hand in hand with microservices. Again, we could have walked in and said, you need to do contract testing. But what we did is we measured a bunch of data first, and we could see that, again, this monolithic thing was slowing them down because of the coupled releases. So actually, you had a big monolith here and another big monolith here, and systems A, B, and C, and they all needed to move together, and that would really slow stuff down because you could only move at the speed of the slowest member of that trio. So we said, well, let's try contract testing. And so again, I'm not going to go into the technical specifics of it, but being able to tell systems can talk to each other without actually having to integrate them directly and test they can talk to each other. So yeah, we worked with the teams and put some spikes together to see if this would work with their systems, got something up and running, and they're now starting to roll that out as well. So these were our ways of influencing kind of bigger things throughout the organization that were beyond the remit of our team, but ultimately we're going to hold back the metrics that we were trying to improve. So we kind of use those as a way to gently push an idea, give them access to the kind of the skills within our team, but ultimately leave it to the organization itself to improve it. And last, really, is sometimes this stuff is hard, right? I'm sure you've all been super frustrated at times because you clearly think there's a way to improve something and it's just not getting done, or it's happening too slowly, or someone's blocking it, whatever it is. And sometimes you just got to do the right thing. And what I mean by that is just do it and seek forgiveness over permission. Because if you go and say, well, I went away and did this, but here's the result. Look, here are the numbers. It's very rare that someone says, roll that back immediately. They'll get over it very quickly if you've made their life easier. So I'm basically, this is me telling you to go out and cause some trouble, basically, and just improve. If you know deep down it's the right thing to do, then just do it. That's why you're here. That's why you're at this conference. That's why you're hired, because you're smart and you can solve problems yourself instead of just being handed stuff down to do. We're better than that. So yeah, justify your actions with data. And we broke things. We broke deployments a couple of times, and when we did, we're like, yeah, sorry, that was us. We're going to fix it. This is how we fixed it. This is how we're not going to do it again. Just kind of use it as an example to be a bit humble and show you're acting in the interests of the greater good. So that is it. That was a whiz-bang tour through.